Welcome back to the Obby series. In today's episode, we're going to be setting up the state manager. And if you're unfamiliar with what a state manager is, it's basically a way of managing the player's data, which we actually already kind of do that in our game. But today, we're going to be furthering that system so that we can replicate or transfer the player's data from the server side down to the client side and always keep it updated on the client side at all times. And look, if any of that sounded confusing to you, don't worry. It might sound like a big task or something that's hard to understand, but as we go through this process, I guarantee that you'll have a much easier time actually understanding it and implementing that directly into your game. With all that being said, let's hop right into Studio. Now, before we begin scripting or implementing the state manager into our game, I want to quickly touch on what a state manager actually is, what it does, and why we need it. Now, currently we are already managing the player's state in a way, and that is on the server side. And to be as specific as possible, we're doing that inside of the server script service, inside of the services folder, and inside of the player data service module script. And the way that we're managing the player's state currently is when the player joins the game for the first time, we will call the create profile function, which will load the player's data from the profile store, and then we'll add that to the profiles table. Then inside of here, we also have the update state function, which is a function that we can use to modify the player's state. And then we also have the get state function, which is a function that we can actually use to get the player's state inside of other scripts on the server side. And the last thing that goes into managing the player's state is actually cleaning it up once they leave the game. So once they leave the game, we use the profiles release method, which will clean the profile up and then actually remove that player's profile from the profiles table. So now that we understand how we're managing the player's state on the server side, where this falls short at is actually on the client side. And what I mean by that is on the client side, we're unable to access the player's state because we've only set it up on the server side and we do not communicate any of the player's data or the changes to it over to the client side yet. Now, with that being said, we're actually using one very small part of the player state on the client side already. And what I'm specifically referring to is the stage progress bar GUI that we created in the last episode. So inside of this script, we can actually see that we're using the leader stats in order to update the progress amount. And we're only able to do this because of how Roblox's leader stats and number values actually work. When we use the leader stats, those are automatically replicated and updated to all the clients in our game. So that's why we're able to access the player's stage information right here. And while it might sound convenient that this is automatic, I'm not a fan of relying on number values or different things like that. And also, using this method, it will require us to create string values and pretty much just a ton of different values that we would use for every single aspect of our player's data. And honestly, there's just much more efficient and organized ways to do that rather than using it this way. The only reason that we used the leader stats in this way originally was because I wanted to create a GUI and I wanted to display the current stage that the player was on in that GUI. And I had planned that we were going to actually create the state episode after creating that GUI episode, which is what we're doing right now. So yeah, for the rest of the series, you'll never actually see us using the leader stats in this way again. Instead, you'll actually see us using the state manager that we're going to create on the client side. Anyways, with that all being said, hopefully that helps you understand what a state manager is, what it does, and why we actually need it. And if you're still a little bit on edge about it, don't feel bad. Like I said at the beginning of this video, I guarantee that by the end of this, you'll have a much better understanding of it, and it'll be so much simpler. Now, to begin implementing the system into our game, the first thing that we're going to do is actually set up the networking. And what I mean by networking is a way for the server to communicate with the client. And if you're unsure about what I mean by the server and the client, I'll leave a link down below in the description to the official Roblox documentation on this subject, because I think this page is actually great and really easy to learn from. But if I wanted to summarize it in just a couple of words, what I would say is the server is the server script service and the client is the starter player. And more specifically, mostly the starter player scripts. So the client or the starter player scripts is unable to access anything in the server script service because you would never trust a client with accessing anything on the server. At the end of the day, we want the server to be in full control of our game, because if the opposite was true, then that means that players would have unlimited grounds for exploiting in our game and could do literally anything they want if the server was not the primary authority. So because Roblox Games use the server client model, what we need to do is create a way for the server and the client to be able to communicate with each other. And how we can do that is by actually using remote events. Now, I'll explain what remote events are in just a second, but let's start actually doing some things. So we're going to go inside of the replicated storage and we're going to create a brand new folder. We're going to rename this folder to be called Remotes. And then to make us even more organized, I'm going to create another folder inside of here and we're going to rename this to be called Player Data. Then inside of the player data folder, I'm going to go ahead and add a remote event to this. Now, before I forget, I want to point out that the reason that we're doing all this inside of the replicated storage is because the replicated storage is able to be accessed by both the server and the client side. So that's the reason that we create the configs folder inside of here and everything else that we create inside of here as well, because everything we put inside of here is what we're going to want to access on both the server and the client side. If we were to store all of these things inside of the server script service or the server storage, for example, then the client would not be able to access those things. So that's why we're storing these all inside of the replicated storage. Anyways, going back to the remote event, basically remote events allow for the server and the client to communicate with each other. Now, you should already know what events are. Like for instance, we listen to the player added event when we're setting up our player data. And of course, the player added event is fired off whenever a player joins our game, and we listen to that event so that we can actually load their data. And then we also connect to the player removing event, which is fired off whenever the player leaves the game, and we connect to that in order to clean up the player's data as they're leaving. Now those of course are pre-made events made by Roblox. Come to think of it, inside of the player data service, we even used a bindable event as well, which we called profile loaded. So when we load the player's data, we actually fire off the profile loaded bindable event, which we actually listen to inside of the respawn service. So we connect to this event, and when the player's profile is actually loaded, we go ahead and respawn them, and then we also listen to their character added event as well. Now, going back to the remote event, today we'll be firing off a remote event from the client side to tell the server when the player has fully loaded in. And in addition to that, we'll also fire off a remote event from the server side to communicate to the client all of their profile data. So hopefully that makes remote events easier to understand. At the end of the day, remote events allow for communication between the server to the client or from the client to the server. And with that being said, let's go ahead and actually rename this first remote event. And we're going to go ahead and call this start. The reason that we're calling this start is because this remote event will be fired from the client side, telling the server that we have fully loaded into our game and our state manager is ready to receive the initial data. Now let's go ahead and create another remote event. And what I'm going to do is actually duplicate this rather than clicking this plus icon and adding one that way. And to duplicate this, we've already gone over this. You hit Control and D, or if you're unsure, you can also right click and then figure out the keybind that way as well. Now for our second remote event, we're going to go ahead and call this set data. Now this remote event will be fired from the server side, giving the player their saved data. And this remote will only fire a single time, which would actually be after when the client uses the start remote event. Now going back to the start remote event for a second, and hearing my explanation, you might be thinking we could just listen to the player added event and then fire off the set data remote event just like that. The reason that we're not able to just listen to the player added event and do it that way is because we're unable to guarantee that the player has fully loaded in and all their scripts have been required and loaded and everything like that. So if the server fires off the set data remote event before the player fully loads in, then they would miss out on their initial data. That's why when the player first joins the game inside of our state manager, what we're going to do is fire off the start remote event, because at that point we can guarantee that we are ready to receive our data. So we'll communicate that to the server, and then the server will use the set data remote event to communicate back to us with our actual data. Now we're going to create one more remote event. So I'm going to go ahead and duplicate this, and we'll go ahead and call this one update data. And now this remote event will be fired from the server side every single time the player's data is modified. And we'll use this to keep the client state in sync with their data on the server side. And with that being said, we've now created all of the networking that we need, so we can go ahead and collapse both of those folders, and we can actually collapse the entire replicated storage. And the first thing that we're going to do is actually go ahead and update the player data service. So we'll go inside of the server script service, inside of the services folder, and open up the player data service module. Now, inside of here, towards the top of our script, but below our update state variable, what we want to do is create a variable for the remotes folder that we just created inside of the replicated storage. So we're going to create a variable called remotes, which is going to be equal to replicated storage.remotes. And then because the only remotes that we are actually going to use are the ones inside of the player data folder, we're going to go ahead and set the variable just like that. Now that we can easily access our remotes, the next thing that we want to do is go inside of the onStart function. Now, inside of the onStart function, we want to actually connect to that start remote event that we created earlier. So we're going to say remotes.start, and now we need to use a property of this called onServerEvent. We see that we also have the option for onClient event as well, but we want to use the onServer event because we're scripting this on the server side right now. Then we'll use a colon, and we can go ahead and connect to this remote event. Then inside of here, we're going to go ahead and create an anonymous function, And we'll go ahead and accept the suggestion for us. And we should see that when we accept it, we actually get an anonymous function created with the first parameter being a player. Now we can also see that it automatically included a second parameter as well, which we're not going to use, so we're just going to go ahead and delete that. Now again, when is the start remote event actually going to be fired? Well, it'll be fired from the client side whenever the player has actually loaded in. So when this remote event is fired off, what we want to do is communicate to the player their actual player data. So the first thing that we want to do inside of here is check if we already have the player's data. So we're going to create a variable called data, and we're actually going to use the getState function that we created earlier, and we'll go ahead and pass through the player. And now we want to use an if statement, and if we do have the player's data, then we know that we can actually use their data. But if we don't have the player's data, then we of course do not want to communicate anything back to the client because we don't have anything to give to them. So now that we know that we actually have their data, how can we communicate that to the client? Well, we'll go ahead and use another remote event that we created earlier as well. So we'll say remotes, and the remote event that we're going to use this time is called setData. And the way that we're going to use this is by using a method on it. So we'll go ahead and use a colon, and the method that we're going to use is called fireClient. Now, when using a remote event and using the fireClient method of it, the first argument that we need to pass through to this function is actually the player. So we'll go ahead and pass through the player that we want to fire this off to. Then we'll use a comma because we want to include a second argument. And now we can include as many arguments and whatever we really want to here. So we could even have 5 different arguments if we wanted to, but in this scenario, we're only going to have one additional one. And what is that additional argument going to be? Well, of course, it's going to be the data because we want to communicate to the client their actual data. Now, you might think that we're done, but there's still a little bit more to do. The reason for this is because we're using an if statement. So what if the start remote event is fired off from the client side, but we don't actually have the player's data yet? Well, if we don't have their data, we still need to get them their data once it's actually loaded in. So in order to give them their data once it's actually loaded in, we can go ahead and update the create profile function. So let's go down into this function. Now that we're at the create profile function, let's consider when we want to actually fire off that remote event to the client side to give them their data. And when do we want to do that? Well, we pretty much want to do it as the last thing inside of this function. So after we add the profile to the table, after we create the leader stats, and after we fire off the profile loaded bindable event as well, we'll go ahead and say remotes.setData fireClient. And who do we want to fire this off to? Well, we want to fire it off to the player that we just loaded. And what do we want to fire off to them? Well, we would want to fire off their profile.data. So we would want to send them their data. So with that being said, we're now guaranteeing that the player will receive their data, whether that's as soon as their profile is loaded, or if their profile has already been loaded, then right after the start remote event has been fired. But there's one more thing that we need to do inside of the player data service, and that is implementing the update data remote event that we created earlier as well. Now, where do we want to implement that remote event? Well, we would want to implement that inside of our update state function. So inside of this function, the last thing that we'll do inside of here is communicate to the client the action that we just used to update their state. So we'll go ahead and say remotes.updateData. Again, we'll use fireClient. We want to communicate this to the player of the state that we just updated. And what do we want to communicate to them? We want to actually communicate to them the action that was just used to modify their state. And we're doing that because we can easily perform the action on the client side as well. Because in order to update the player's data or state, we're simply using the shared function update state that we created inside of the server script service. So as long as we have the action, we can easily modify the player's data the exact same way on both the server and the client side without having to do any extra work. And with that being said, that's all that we actually have to do inside of the player data service. So just to recap this, inside of here, what we just did is we implemented getting the player state to the client, whether that be when they join the game or when their profile has loaded. And then every single time we update the player state, what we're doing is communicating that to the client by telling it the action that we just performed on its state. And then, of course, when we receive that on the client, we'll go ahead and update the player state to reflect what it should look like directly on the server side. So now that we've done all that, we can actually go ahead and close out of the player data service. Now, we need to do one quick thing before we begin implementing the state manager on the client side. And what we need to do is make a slight change to the update state module that we created inside of the replicated storage. So we'll go inside of the replicated storage, inside of the functions folder, and open up the update state module script. Like I said, it's a very small change that we need to make inside of here. And what we want to do is we want to export another type from inside of here. So we're going to say export type, and the type that we want to export is actually the player data. So we'll go ahead and say player data. And what this type will be is the exact same type that we created inside of the player data module that we're already requiring inside of here. So we'll just say player data dot player data. And now what I would call this is basically re-exporting a type, And the reason that we're doing this is so that anytime we require the update state module script, we can easily reuse the player data type rather than having to require the player data script which originally created this type every time that we want to actually use this type. It basically just saves us some time, and it's really simple and easy to do. And that's all that we needed to do. So we can go ahead and close out of this and collapse the entire replicated storage. Now, with that being done, we can finally get started with actually creating the state manager on the client side. So to do this, we're going to go inside of the starter player, inside of the starter player scripts, inside of the controllers folder, and we're going to go ahead and create a brand new module script. We'll of course go ahead and rename this module script to be called state controller. And as we do for every single module, let's go ahead and update the module variable. We'll go ahead and rename this to be called shared, and we'll go ahead and create our local variable inside of here as well. Then the first thing that we're going to do inside of here is go ahead and create a variable for the replicated storage. So we'll say replicated storage, and to get the replicated storage, we'll use the game variable, then the get service method, and the service that we want to get is the replicated storage. And now we want to get two things from inside of there. The first thing that we want to get is actually the update state function. So we'll go ahead and create a variable called update state. And since this is a module script, we'll go ahead and use require, and we'll go ahead and require the module script inside of the replicated storage, inside of the functions folder, and the module script is called update state. In addition to requiring that module script, we also want to create a variable for the remotes folder that we created earlier. So we'll go ahead and say replicated storage.remotes, and the only remotes that we're going to be using are the ones inside of the player data folder, so we'll go ahead and set the variable just like that. Then we want to go ahead and create another local variable, and we're going to call this state. Then we'll specify the type of this, and we want to set this to the player data type. So we'll go ahead and say update state.playerData because we just added this type to that module script. And the reason that we're creating this as a local variable is so that we can actually specify the type of it. If we were to say create that state variable inside of, say, the local table, you're not actually able to specify the type of a variable inside of a table. So what we would really do is set this variable to the local state variable that we created, because that's kind of like a workaround for how we could do this. But it's just completely unnecessary to add it to the local table, so we're not even going to do that. Now that we've done that, we're going to go underneath of our shared table, and we're going to create our first shared variable. So we're going to say shared, and this variable is going to be called update state. And wow, I didn't realize, but Roblox updated Studio with AI, so now I actually have a function suggested to me, but we're not actually going to use that. Because what we actually want to set this variable to is a bindable event. So we'll go ahead and say instance.new, and then what is the instance that we want to create? Well, that would be a bindable event. Now, we'll use this bindable event inside of other scripts on the client side in order to perform actions whenever the player's state has been updated. We'll commonly use this inside of UI scripts to update the UI whenever the state changes as well. The next thing that we're going to do is actually create the onStart function. So we'll go ahead and say function shared.onStart. Of course, this is not going to have any parameters. And the first thing that we want to do when the script starts up is actually connect to the setData remote event. So we'll go ahead and say remotes.setData. And to connect to this, we need to use the onClient event property because we're on the client side. Then we'll use a semicolon. And now you might think that we would use connect, which we completely can use connect here. But instead of using connect, we're actually going to use the once method. The difference between once and connect is that if we connect to this remote event, we will always stay connected to it unless we actually disconnect from it. But if we use the once method, we will connect to this event and then automatically disconnect from it after the server fires it off and the client receives it for the first time. So, as the name says, we're only going to actually use this remote event one single time. Now, like I said, you can use connect as well. Once really doesn't matter. It's like a micro optimization, but it's just a really simple thing to understand, and I think it's nice to know these little different things that you can actually do. Anyways, let's go ahead and create an anonymous function inside of here. And now this function's only going to accept a single parameter, which would be the player's data. And we can specify the type of this as well to be the update state.playerData. And now, what do we want to do inside of this function? Well, we're simply going to actually set the value of the state variable that we created earlier to the player data, which is passed to this remote event. And that's actually all that we're going to do inside of this function. Now remember, the setData remote event is really only ever going to be fired one single time. It could possibly be fired twice, but we really don't care if it's fired twice, so that's why we're using once. And it should only be fired when the player first joins the game and their client is ready to receive the data, or if the client is already ready to receive the data, but the profile wasn't loaded at the time, then it'll be fired off when the profile is actually loaded. Now, after that, still inside of the onStart function, we have to connect to another remote event as well. This time we'll connect to the update data remote event, so we'll say remotes.updateData.onClientEvent, and we want to use the connect method here. We'll again go ahead and create an anonymous function, And what we're going to get passed to this function is actually the action which was used to modify the player's data. So we can specify the type of it to updateState.updateState action. Now, the first thing that we're going to do inside of this function is actually check and make sure that the state has actually been set before we try to update it. So we'll say if not state, then, and then we'll say return end. So we'll stop the function right there and avoid updating the state if we don't actually have the state yet. Now, ultimately, that should never actually occur, but just in case it does, it doesn't hurt us to just include a single simple if statement, so that's why we're doing it just like that. Now that we know that we actually have the player state, let's go ahead and update it. In order to update it, we're going to use the updateState function, and we need to pass through the player's data. So we'll go ahead and pass through state, and then we need to pass through the action. So we'll go ahead and pass through the action as well. So after we've called that function, we then know that the state has been updated to accurately reflect what the player state actually looks like right now. And because of that, we'll go ahead and fire off the updateState bindable event that we created. So we'll go ahead and say shared.updateState, and then we'll use the fire method. Now we want to pass a couple of things through this event. The first thing that we want to pass through is the action. And the second thing that we want to pass through is the state. Now we don't actually need to pass through the state here, because of course, if another script is already using the updateState bindable event, then they could also just access the state. Technically, you probably don't know that, but eventually we will actually create a shared function for accessing the player state. But the reason that I'm saying that is the only reason that we're including the state here as well is just for convenience. Sometimes we might actually want to have access directly to the state instead of having to listen to the bindable event and then grab the player state on our own. It's just simple and really doesn't cost us anything to pass through the state as well. And with that being said, we're also finished with setting up the update data remote event inside of here as well. Now, after we've connected to all of those events, we can go ahead and fire off the start remote event to let the server know that we're ready to receive our data. So we'll go ahead and say remotes.start, and then we'll go ahead and use the fire server method on it. And like I said, that'll let the server know that we're now ready to receive our data, so they can go ahead and use the set data remote event to communicate that to us. Now, also, just in case you're confused at all, when we use a remote event on the client side and we use the fire server method, you might be thinking, well, do we have to pass through the player to this function to actually communicate to the server what player is using this? And no, we don't actually have to do that at all. When we use the fire server method, Roblox automatically handles that for us and will tell the server side, anywhere that we actually listen to this remote event, hey, this is what player actually fired that off, so we don't actually have to pass through the player when we use fire server or anything like that. Cool, so now we're completely finished with setting up the onStart function, but we have one more thing left to do, and that is creating a shared function for actually accessing the state on the client side. So we'll go ahead and create a function. It's going to be a part of the shared table, and it's going to be called getState. It's not going to have any parameters, but we also want to specify the type of this as well, so we'll go ahead and use a colon, and the type of this is actually going to be the player's data. So we can go ahead and say updateState.playerData. Now, what we want to do inside of this function is we want to actually use a while loop, and I'll explain this whole process in just a minute, but first follow along. So we're going to use a while loop, and for the condition, we only want this while loop to run while the state has not been set. So we'll say while state equals nil. So while the state has not been set, what we want to do is we want to actually stall any script that uses this getState function. Now, what I mean by stall is we want it to pause or stop right there and wait for the state to actually be loaded before it actually proceeds. And to do that, we can use task.wait, and the amount of time that we want to wait is 0.01 seconds. So we really don't want to wait much time at all. Then after that while loop, the final thing that we want to do is actually return the state variable. Now, this might be a little bit confusing to you. So to make this easier to understand, this function is commonly going to be used inside of other scripts. Many of those scripts will actually manage the UI. So we want to stall those scripts from running until the player's data has been loaded. If we did install those scripts, then the UI script would experience errors and break because they're going to try to access and use the player's data before it has actually been loaded. So this while loop will only ever possibly apply when the player joins the game for the first time and their data has not been loaded yet. But after their initial data has been loaded, then this while loop will be skipped entirely because it no longer is nil. And with all that being said, we've actually fully set up the state controller, aka the state manager on the client side. So let's go ahead and actually use this. I'm going to go ahead and close out of this module. And where can we use this? Well, we can actually use it in the script where we handle updating the stage progress bar towards the top of our screen. So we can go inside of the GUIs folder, inside of the top folder, and open up the stage module script. Now, inside of the script, I'm going to go ahead and create another variable below the GUI controller variable. And this variable is going to be for the state controller. So we'll create a variable called state controller. And to get the state controller, of course, we'll use require. Then we'll say script.parent.parent.parent. .stateController. And now the reason that we're creating this variable right here, rather than creating it below the stages config, is simply because I like to group all of my controller variables together. If you want to put it below stages, it literally doesn't matter, but this is my way of staying organized. Now we've gotten the state controller, let's take a look at our onStart function and our update progress function. Of course, looking at the onStart function, we can clearly see that we're using the leader stats right here in order to use the update progress function and update the progress bar towards the top of our screen. But now, instead of doing all that, let's just go ahead and delete everything inside of the onStart function. In addition to that, let's then go ahead and update the update progress function. What we're going to do is actually remove the parameter from this function so that it can be called without passing through any parameter to it. Then we'll go inside of this function and we're going to create a brand new variable, which is going to be called current stage. Now, to get the current stage that the player is on, we of course need to use the state manager, aka the state controller. So we'll say state controller, then we'll use the get state function. And now that we're accessing the player's data, what do we need to get? Well, of course, we need to go ahead and get their current stage. So we'll say .stage. Now that we have the current stage that the player is on, we can go ahead and update the stage variable right here and right here. And now that's all that we have to do with this function. With that being said, we've now just made this function a lot more dynamic. Although it is a local function, so no other script would actually use this, imagine if this was a shared function. If it was a shared function, we could easily call it from every other function without having to do a single bit of extra work. Previously, if we wanted to use this function, we would have to get the player stage and then pass it through to this function, which even now, it's not a lot of work, but what I'm trying to say is that by doing this and including the state directly inside of this function, it just takes a lot of work off of our back and makes it a lot easier to use that function in some ways. With that being said, let's go back to the onStart function. And when do we want to use the update progress function? Well, we of course need to call that when the script starts up for the first time, because of course when the player joins the game, we want to accurately display what stage they're actually on. So let's go ahead and directly call the update progress function. But that's not the only time we want to call this. We also want to call this whenever the player's stage actually changes as well. And we can easily do that by using the update state bindable event that we created inside of the state controller. So we'll say state controller.update state.event, and then we'll go ahead and connect to this. Now, what do we get passed through to this function? Well, the first thing that we get passed through is the action. And we can specify the type of that by saying state controller. Oh my gosh, I thought this video was flawless, but of course I made a mistake. As I was creating the state controller, I kind of considered it for a second, but for some reason I just didn't recognize it. Before we're able to specify the type of this, we need to re-export the action type from the state controller. So let's go back to the state controller. Then between our remotes and our state variable, this is where we'll go ahead and export the type. So we'll go ahead and say export type. We'll call this update state action. And to get that type, of course, that's inside of the update state module. And of course, that is the update state action type. In addition to exporting that type, let's also export a second type, which would be the player data. And how are we going to get that? Well, that's also inside of the update state module. And we want to export the player data type just like that. Okay, with that being said, we are officially finished with the state controller. Let's close out of that, go back to the stage module. And now, like I said, we can go ahead and specify the type of this action using the state controller. And the type of this parameter would be update state action, just like that. Now, in addition to getting the action, we also get the player state included with this as well, so we can specify the type of this as well to be stateController.playerData. Now, we're not actually going to use the state in this function, so I'm going to actually not include that here, but I just wanted to show you that you can include that here because we do also get that information passed to us as well. Anyways, inside of this function, what we could do is we could instantly just go ahead and call the update progress function every single time the player state is updated. But the thing is that we update the player state many times and in many different ways. I mean, currently we only update it if their stage changes or if they receive a death. But in the future, imagine when we add a lot more systems, like their settings or them rebirthing or different things like that. All those extra systems that we implement are just going to increase how often we actually update the player state. So to optimize this and care about the performance a little bit, what we can do is choose to call the update progress function based on what action has actually been ran. So we'll go ahead and use an if statement and we'll say if action.type equals, and now the action that we're going to listen to is the update stage action. So if we update the player stage, then of course we want to go ahead and call the update progress function just like that. And with that being said, that's all that we have to do inside of this script. So we're updating the player's progress when the script starts up for the first time, and every single time their stage has been updated on their state. And of course that'll happen every time the player reaches a new stage. So with that being said, we can go ahead and close out of that script, collapse the entire starter player, and actually go into our game and test this out. So as soon as our game starts up, we can see that the progress bar is accurately displaying the same thing that we're seeing on the leader stats, so we can clearly see that on the leader stats we're at stage 5, and in the progress bar we can also see that we're at stage 5 as well. Let's make our way over to the next stage and see if the progress bar updates as well as the leader stats. So we reach the next stage, we can actually see the stage has increased on the progress bar, and if we look at the leader stats, we can also see that it displays 6 there as well. So not only can we see that the state manager is working, we can also see that that state is completely in sync with the server and is actually accurate. Because the leader stats will always be accurate, because that's not affected by our state manager at all. That's only affected by the server side. But of course, when it comes to the state manager, that is all managed on the client side, so if you mess something up or you did something wrong, then your state could get desynced. But clearly, we have set this all up correctly, so that's actually all that we have to do for this episode. Now, before I do my usual outro, I just wanted to kind of explain the benefits of using this sort of state manager. If we take a look inside of the replicated storage, we can see all of our remotes. When I first began scripting, the way that I would set my games up is by basically having a remote event for every single action that occurred inside of my game. So I would have a remote event for updating the stages, updating the defs. If we had settings in our game, I would have a remote event for updating settings. Then if we had something complex like a pet system, I would have a ton of remote events. One for equipping the pet, unequipping the pet, locking the pet, deleting the pet, and all those other things that come with it. And now that's a perfectly acceptable way to set up your game, but after the years of me scripting, I finally saw this method of replication and state management being used, and I felt like there is no better way than this. It's really simple to set up. It only requires 3 remotes in total, really just one remote for communicating the state from the server to the client, compared to the tens or hundreds of remotes that you would have for communicating all of the different pieces of data that you would. Not only does it save you time and organization from creating all those remote events, but because of the update state function that we created inside of the replicated storage, it saves us a ton of time by preventing us from having to rewrite updating the state on both the server and the client. Now, looking at the update state function, the only real downside that I see here is at first, this may look very confusing and you're probably not going to be used to this method at all. So it might be a little bit hard to get over or get used to, but of course, as we add more systems and add more things to the player's data, which of course would force us to update this module script, to implement more logic for actually updating the player's data, then you'll get more comfortable with it as we interact with it more often. So yeah, that's why we're managing the state this way, and that's also why I'm replicating the state from the server to the client this way as well, because while it might be just a little bit more confusing at first, I feel like it saves us a ton of time and provides a bunch more advantages in many different ways. Anyways, ladies and gentlemen, with all that being said, that's going to be it for this episode. I hope you enjoyed, and if you did, make sure you go down below and smash the like button. While you're down there, please leave a comment down below if this did work for you, because you might be watching this video much further out in the future, and other people might go down below in the comments saying that they have issues thinking that the series is outdated. So not only will you help me, but you'll also be helping other people realize that they might have made a mistake on their own and the series is not outdated. In addition to that, if you want to support me in another way, you can also feel free to go down below in the description and visit either MonzterDev or my Patreon. If you support me on either of these sites, you get access to a ton of assets such as GUIs, icon packs, models, games, scripts, and even everything that we created in today's episode as well, while also financially supporting me and making these videos possible. But anyways, with all that being said, I hope that you have a great day, and I'll see you guys in the next episode.